All right, here we go. Multiple choice questions. Let's do this. Convert any angle in radians to degrees. It must be multiplied by, and again, if you've forgotten, you can always stick to the simple idea. 2 pi is equivalent to 360 degrees. So if you want to convert radians to degrees, first you've got to find out 1 radian. So the only way to get 1 radian, divide both sides by 2 pi. And this will cancel out to be 1 radian. Okay. 1 radian is equal to 360 on 2 makes it 180 on pi. So you can see why, how do you convert radians to degrees? So if I had 2 radians, then I would need to multiply this by 2 to get from 1 to 2. But then on the right hand side, to keep it equivalent, I'd have to multiply this by 2 as well. And that's obviously then the degrees. I'm just double checking that I've done it right. Radians 2 degrees. Yes. That should be correct. 2 times 180 divided by pi. Let me just double check. So if I times it by pi on 2, yeah, that works. So if you wanted radians here, if you wanted to get to pi on 2, which we know is 90 degrees, times it by pi on 2. From 1 to pi on 2, you have to times it by pi on 2, but that means you multiply the right hand side by pi on 2. And you can see the pi's cancel out. 180 divided by 2 is 90 degrees. So it is true. Times by 180 and pi. Okay. So it will give you B. For those who can't be bothered going through that, I guess you can memorize that as well. Okay. Next one. Let's go with the graph which has an amplitude of 2 and a period of pi could have a rule given by. Now, if you have an amplitude, clearly it can't be tan. So any tan questions are out of the question. Amplitude is the number in front of the function, so it can't be this. It could be B. It can't be this because it's adding 2. It could be this because there's a 2 in front of the function, and it can't be this. So you're really down to B and D, but you want a period of pi, and remember period is 2 pi on n. So obviously in order to have pi, n would have to be 2 because then 2 divided by 2 cancels out and you get pi, right? So that means if n is 2, n is the number in front of x, and you can see this is pi and this is 2. So therefore, D must be your answer. Okay. Hopefully this is going to go a bit faster. The other one took me an hour to do a half-an-hour question. Let's see. D, the graph of this has a minimum value of. Now, for me, I can picture the graph. If you can't, type it in your CAS and find the minimum value. So just in case you couldn't visualize it, go to your CAS, control, document, add a graph. You got 3 times cos, which is over here, trig button. You got a cos of, what was it again? Let's go back. 2x, 2 times x, minus 1, so minus 1. There you go. Press enter, and the minimum value, as you can see, is down here. You can use menu 6, menu 6, so analyze 2, which is minimum, and you can just check out what the y value is, and clearly it's -4, and so the answer is E. Okay. But if you didn't want to do that, you could have just tried to figure out the graph amplitude of 3. So normally it would have been 3, -3. Cos graph looks like this, but it goes down by 1. That tells you down by 1. So 3 comes down to 2, and then -3 now comes down to -4. So the new graph will start here and finish there. So it's gone down by 1. Okay, we're not interested in period. We're only interested in the minimum value. So you could have done that and you would have got the answer, or you could have sketched it on your CAS. CAS will be your savior when you're doing multiple choice. Okay, so learn to use the CAS. Next one, if sine of theta is equal to 5 on 13, and theta is between pi and 2 to pi, which is the second quadrant, then cos of theta is equal to. Okay, now when you have to sort of try to picture in this case here is, what's the scenario? You've got sine of an angle between, where angle is from pi on 2 to pi. Okay, so from here, let's say the angle makes it like that. So this is my triangle. This is the angle theta. Okay. Sine, what you have to understand is sine back in year 9 is opposite over hypotenuse, right? But since the answer is 5 on 13, what does that mean? It just means opposite must be 5, hypotenuse must be 13. Okay, if you keep to that idea, then drawing out my triangle with the angle theta here, which one's my opposite? This is my opposite, this is the hypotenuse, and this is my adjacent. So if this is 5 and the hypotenuse is 13, well, let's find A using Pythagoras' theorem. Pythagoras' theorem, we know that it's 13 squared equals 2. So C squared equals to 5 squared plus A squared. Yeah, you can do that on your calculator. Going back to this, so 13 squared minus 5 squared should give you 144. So that means this must be 12. So A must be 12. So why do I need to know A? Because they're asking for cos of theta, and we know cos of theta is equal to adjacent over hypotenuse. Adjacent is 12, hypotenuse is 13. So it's 12 out of 13. But what you need to also pay attention to is that cos, so this is your angle, cos represents the x coordinate, true? So at this point, because we know it was theta starting from pi and 2, this coordinate here, x and y, the x coordinate is clearly a negative value. So we just found out that it's 12 on 13, but keep in mind, it's in the negative x-axis, so it's negative 12 and 13. Okay, so it should be C. Now, if I remember correctly, in our paper, or SAC, a lot of people were getting this one wrong. It's the symmetry properties from the vertical axes. If that's confusing, you can look at it again if you want. I don't think you should spend too much time trying to. If you get it, great. If you don't, move on. It's only 1 mark, and you'll probably find another one that's easier to do. Okay. Question 5. Find the function. With the function has a period. It's a tan graph. Remember, the period for a tan is not 2 pi. It is pi on n. And our n value, be careful here, x on 3 is the same thing as writing 1/3 x. So the number n is equal to 1/3. So you're really doing pi divided by 1/3. And hopefully, if you don't know how to do that by hand, do it on your CAS and you'll get your answer. But pi divided by 1/3 is the same thing as saying pi times 3 on 1, which is 3 pi. Okay, so the period is 3 pi. And that's B. Okay. Next one. 6. The function a to infinity g of x is equal to log x minus 1 has a maximal domain. For me, I'm all about, being able to visualize the graph. If you can't, sketch that graph. Or if you knew the property for a log, what can't you log? You can't log a negative number, okay? So it just means right here, x minus 1, that always has to be positive. That's essentially what we're trying to say. We can't log a negative. You can try it in your CAS right now. I'll do it with you. If you did log, say, ln, log of 3, it's okay. You get an answer, right? So it's 1.09. But if you try to do ln of, let's say, negative 3, undefined, no result. If you tried negative 1, no results, okay? Because you just can't. A logarithmic graph, if you've forgotten, this is what a log graph looks like. I'm just going to draw it. ln of x. Notice here, this is my graph. This is the graph of a logarithmic. And you can see there's an asymptote at x equals 0, and there's no negative values on the left. That's why we know that on the x-axis, no matter if you sub a negative value in, it's never going to give you any answers. That's why when you say log e of x, if the x values are negatives, it's going to be undefined. So basically, when they ask you what is the maximal domain, you just got to make sure that x minus 1 is positive. So it's greater than 0. So if you actually solve for it, x is greater than 1. Okay? So any number greater than 1 should be okay. Alright, so, and that makes sense. If I put 1 in, 1 take away 1 is 0. That's a problem, because remember we said the asymptote is on 0. You can't have log e of 0. Watch. If I do ln of 0, ln 0, it's undefined as well. Okay? You can't. There's an asymptote. Look at the graph again. You have an asymptote right on the y-axis. So you can't have x equals 0. So that's why even if you just substituted, values in, if you put a 1 in, it didn't work. 1 take away 1. If you put in 0, 0 take away makes a negative. You can't do that. And any number greater than 1, so even if you have 1.5, that works because you can do log e of half. That's okay. It's bigger than 0. Okay? So in our case here, anything greater than 1 will work. So out of this list, which one is greater than 1? Clearly, it's not negative infinity. Clearly, because we're trying to find that a value. In the graph, we're trying to find what's the smallest a value all the way to positive infinity. But we just said x has to be greater than 1. So clearly, any number where a is bigger than 1, so from 1 onwards, a could be anywhere. Okay? And we know that it can't be 0 because 0 is less than 1. We know that it can't be 1 because we said greater than 1. The only one that's greater than 1 is e. Okay, so that's why it's that. If you can use transformations, everything I taught you, sketching logarithmic graphs, you should have been able to look at that and say up by 2, to the right by 1. And so if I would draw the graph, it's gone to the right by 1, so it's an asymptote at x equals 1, and the shape looks like that. So you can tell already that the domain has to be greater than 1 to infinity, and none of these would have fit into that picture there. Okay? I know I haven't shifted up by 2, but it really doesn't matter. You're interested in the domain, so even if you shift it up by 2, it'd still be something like that. Okay? So it's all about picturing the graph, and if you couldn't do it, type in the CAS to notice it, or notice the property that x minus 1. So log of whatever this thing is has to be greater than 0. That's the point, and you can solve for x from there. Okay. Next one. The coordinates of the point on the graph y equals x squared minus 6x plus 5, at which the tangent is parallel to the line. Okay, it's a mouthful, but look, you're trying to find the coordinates to this graph where the tangent is parallel. Now, parallel means that the gradient is the same as the gradient of this line. Now, what's the gradient of this line? 2. So that means parallel means gradient is 2. That's what they're trying to say. So they're saying this tangent line has a gradient of 2. Remember back to, derivatives. Derivative is the gradient. So if I found the derivative of this, so dy dx, x squared minus 6x plus 5, if I want to find the derivative of that, that's 2x minus 6. Now the gradient's 2, so that means the derivative, dy dx, has to equal to 2. You can solve that. You can do 2 equals 2x minus 6, add 6 on both sides, that becomes 8 equals 2x, and then divide both sides, x equals 4, right? You could do all that by hand, or if you had known, do it on the CAS the way I showed in the last session or the last video I showed. I would have said define f of x equals to x squared minus 6 times x plus 5. Was it plus 5? Yes, plus 5. Define g of x, which is the derivative. So shift minus gives you the derivative, and f of x. Okay, and what are you trying to do? You're trying to solve. So menu 3(1), solve for g of x to equal to 2, because the gradient, we want it to equal to 2. Solve for x, so you get x equals 4. Yeah, same thing, same drill. Now, it says coordinates. So when x equals 4, how do you find the y value? Sub 4 back into the equation where it tells you what y is. So since I define it as f, I do f of 4. It's negative 3. So 4, negative 3, and there you go, C. Okay. Then you use your CAS. You can do it by hand if you wanted to, but I'm just showing you how to use your CAS quickly. The equation of the normal. You can do this on a CAS very quickly. Okay, here we go. Instead of doing the whole shebang by hand, do this on a CAS. Here we go. We are going to do menu, calculus. Now notice on the bottom here it says normal line. You can do normal line. What you have to do here is write the expression, write what you're deriving with respect to, and then the number. Okay, so what's my expression? Let's go back. It was 4 times x to the power 4 plus 4 times x to the power 3 plus 8x, comma. Okay, so that's the expression. Okay, and I want to derive it with respect to x, because I'm deriving all the x functions. And at what coordinate tells you x equals -1. So -1. Bam. It works out the normal line for you. So the answer here, oh, well, since they've rearranged it, we've got, what is it? We've got the normal line is equal to -x on 4 minus 33 on 4. Now notice they're both out of 4, so if I actually times them all by 4, then the 4's cancel out, and you get -x minus 33 is equal to 4y. Do we see that? 4y? -x, alright, there we go. Hey, I know they do it by hand in your solutions, if you look at the solutions, but I'm telling you, learn to use your CAS. Okay, there you go. You got your equation. Next one, 9. If 3 log 10 of 4x minus 30 is equal to 3, then they're obviously trying to solve for x, so you can see they're trying to find x's there. Then just type it in your calculator. Menu 3-1. So menu, solve, algebra solve 1. What's the equation? It's 3 multiplied to log base 10. So control log base 10 of 4 times x minus 30. Move the cursor, equals 3, comma x. Bam. X equals 10. Woo! I'm barely doing any mathematics right here. I'm just doing the CAS, aren't I? Yeah, you could have done it by hand too. You could have, you know, tried to do log 10, 3, 4x minus 30 equals 3. Divide both sides by 3. Cancels out to be 1. And then you could have got log 10 of 4x minus 30. You know, get rid of the log 10 by doing the exponential. 10 to the power of this, 10 to the power of that. These cancel out. 4x minus 30 is equal to 10 to the power of 1. And then you can try to solve. So 4x minus 30 equals 10. 40. X equals 10. Yeah? Takes a long time. My point is learn your CAS. Okay? Makes it much easier. You can see the way I'm going through it. I'm really whipping through the questions, and they're not that hard to do. Now, limits. You can't really do much with limits here. We haven't done too much of it, but the aim is you have to simplify the expression. Remember, any fractions you're getting in year 11, simplify first. When I put in the SACs, I actually expected you guys to simplify. Always simplify. Okay, always simplify. So here we go. How do we simplify this? You can't just cross out the x's. Okay, if that's what you were thinking, you can't. There's a minus in between them. You can't do that. If it was times, then you can. Okay, but how do you do this? Notice it's all quadratics. You're meant to use quadratics. Factorize it. Here we go. Factorize x. In the numerator, you get x minus 3. And the denominator, that's a difference of perfect squares. So that's x minus 3 and x plus 3. The x minus 3's cancel out, and you get x over x plus 3. Don't forget, this is the limit when x approaches 3. So if it approaches 3, so we're saying, what if this becomes so close to 3? Essentially, what do you have? You essentially have 3 over 3 plus 3, which ends up being 3 on 6, which is about half. That's what it's approaching. So the answer is D. Okay, that's how you do that question. Instantaneous rate of change. Now, we didn't work through this in our language. It used to be in the language of the course and some kinematics, but for the sake of doing this, instantaneous rate of change just means find the gradient at that point. That's it. Okay, so how do you find the gradient? Find the derivative. Okay, if you find the derivative, that just finds the gradient function, but doesn't tell you the gradient until you sub -1 in. Okay, now you got your CAS, might as well work it, yeah? So here we go. Define f of x equals 2, what is it? 3 divided by x squared. So I would have done this, 3 on x squared Press enter, find the derivative, so shift minus x f of x. That's my derivative, and I said I was going to sub a number into the equation. What number was that? That was -1. So I'm just going to, if you didn't know what I just did, I just highlighted the previous question, press enter, and I changed the x to -1. Notice I put brackets in, otherwise it doesn't read it as -1 cubed. Press enter, there you go, answer 6. Okay, done. All right, so you're essentially just finding the derivative, so dy dx, find the gradient, and the answer to that was -6 on x cubed. But remember, you can't find the gradient unless you sub a point in. So at x equals -1, I just sub -1 in, and it works out to be 6. So that's my gradient. Okay, that's what instantaneous rate change actually just means. Gradient at that point. This one is an antiderivative. Again, you don't have to do it by hand. I'm pretty sure if you look at the solutions, they do it by hand. I'm just going to show you how to do it on the CAS. So here we go. Shift minus was derivative, then shift plus is the antiderivative. Now notice the antiderivative default, it goes to the definite integral. We want an indefinite integral. So just press the backspace or press delete here, press once, and then now you've removed the intervals. Okay. Now type in what you have. You got 2 plus square root of x. That's plus 1 over x cubed, and with respect to x. Bam! Hopefully we can see our answer somewhere. What is that? Minus 1 on 2x squared. That's a 2x. Okay, I feel like the answer is getting very close to E, because you've got the minus 1 on 2x squared, you've got the 2x. It's this one that looks slightly different, but let's think about it. It's x to the power of 3 on 2. Now, x to the power of 3 on 2 is the same thing as writing as x to the power of half cubed. True, I'm just using index laws. And x to the power of half is the same thing as saying root x cubed. Okay? And I'm just wondering if they have that anywhere. Root x cubed. Or square root of x cubed. No, the answer is C. Because you got the 2x, you got the minus 1 on 2x squared. Yeah, some of you might struggle with this one only because of the x to the power 3 on 2. X to the power 3 on 2, because you got, technically, this is what you have. X to the power 3 on 2 is the same thing as writing x to the power of 3 and then square rooting that entire thing. If you really think about it, it's the same as writing that. The question is, why couldn't you write it like this? This is for year 12, where you'll actually learn that this works with a restriction. This will always work, but for argument's sake, just look for the answer. And clearly x to the power of half wasn't there, so this is the other alternative answer. And that's what that is. Square root, because half is square root, and you've got x cubed. So C has to be the answer. Okay, I just used my CAS, by the way, but I can see why. Maybe if you did it, no, even if you did it by hand, you would have had the same issue. So you really needed to know your index laws to be able to break it down and find out that it's C. Okay. Next one, the graph of the function passes through 1, 3. Now remember, in the exam 1, if you were actually watching that, I talked a lot about they will always give you the derivative and x, and they will give you an x and y relationship, right? So they already just gave me, it passes through 1, 3. So when x is 1, y is 3. The next thing is they said it has a gradient function, so you got a gradient there. The rule for f is, okay. Now, one of the things I haven't shown in class, and this is a great opportunity to do it, antiderivatives, I showed you the antiderivatives, but I haven't shown you this logic to it. It's obvious, but I'll show it to you so that you can see why. See, if you do f of x, right? Let's make it easy. Let's call it x squared. If I told you to find the derivative Actually, I'm going to call it y just to make it easy. If I asked you to find the derivative, which is dy dx, you would tell me the answer is 2x. True? Yes. Now, if I asked you to go backwards, how would you do that? If you derive to get here using power rule, then the only way to go back is antiderive. True? But remember, every time you antiderive, you have that plus c. That plus c that you have to put in. Now, antideriving it will give you a plus c, and that's a problem. How do you find the plus c? That's where the 1 and y comes in, because when you bring it back, you get this equation. It's got a y, it's got an x, and you have the plus c. So you get a sub y and x in to find c. Now, if I'm going to do this on the CAS rather than doing it by hand, this is essentially what you're doing. Okay, so we're going to find the antiderivative of the derivative, because they gave me the derivative. Essentially what they've just done is they said y equals to something, I don't know, but I know the derivative is dy dx is equal to, and they gave you 4x cubed plus 3x squared minus 1. So if you antiderive that, it should give you the original function with a plus c. So on your CAS, again, shift plus, press the delete button, and then was it 4 times x cubed plus 3x squared minus 1 dx. This is my expression. Remember, this has a plus c, so it's technically the answer to this part now is x to the power of 4 plus x cubed minus x, don't forget, plus c. So how do you find that c? When x is 1, so if I sub 1 in, y is 3. Okay, so if you solve for that, if you can sub it in by hand if you wanted to, or you can do it on your CAS. I probably would do it on my CAS. I do solve 3 equals 2, 1 to the power of 4, plus 1 to the power of 3, minus 1 plus c, comma c. Find c. C equals 2. Yeah, I know you could have done it by hand, but I'm trying to really show you how to use your CAS. Okay, so that means c equals to 2, and so therefore my equation y is equal to x to the power of 4 plus x cubed minus x plus 2. Which one gives me that? It is D. Okay, D is the only one that has the answer. Cool. Oh, how many? Oh, hey, I'm up to the last one. That was pretty quick. It took me about half an hour to do this. Cool. Okay, so here you go. The temperature, H, inside. And remember, if I'm taking half an hour while I'm explaining, it means that you should be able to do it much faster if you're just focused on doing it with the CAS as well. Anyway, temperature, H in C degrees inside an oven, T minutes after it is turned on is modeled by the function. Look, personally, I would probably just define that straight away before I even do anything. But anyways, it says at the rate at which the temperature inside the oven is changing in C degrees per minute. Okay, this is not on the course anymore, where we're talking about rates. You can ignore this if you want, or you can look at the solutions, but essentially they're just telling you that find the rate means find the gradient at t equals 5. That's pretty much what they're telling you to do. Okay, so if I were to do this question, this is my equation, h of t, which I'll call y. I'm going to define this. I'm going to go define f of x equals 2. You got your fraction, so here we go. Let's put our fraction 3 times, what's this? X minus 10. I know it's t, but I'm going to call it x anyway. Squared over 2 plus 180. So I've defined it. Okay, and then I want to find the derivative and I want to solve it. True? So this is what I'm going to do. I'm going to go menu, solve. Okay, I'm going to do, I want you to solve for the derivative of f of x when it equals, actually that doesn't work. Wait, I got to define the derivative. Define g of x is equal to the derivative of f of x. Okay, so that's the derivative. Now I want to solve for g of x when it's 5. So I want g of 5, sub 5 into the equation. And what am I trying to solve again? No, I just want to find g of 5. Whoops, what am I doing? G of 5. So sub 5 in. Negative 15. There you go, A. Okay, so if you got confused what I just did, this is my y equation. I found the derivative, dy dx. Okay, so the g of x represents the derivative. And right here, I just said sub x equals 5, which technically is 5, t equals 5, sub it into the derivative. Okay, so when I got the derivative, whatever it is, I want to know the gradient. This tells you the gradient. Just sub in the value, x equals 5, and that's what I did, and it gives me negative 15. Okay, but something else to note, I'm just remembering h 0 to 10, t equals 5. Did I forget something? I feel like I did. Sorry, in my defining, I forgot to define with a negative, so my answer was wrong. There you go. Yeah, should be 15, because I forgot the negative there. Ah, my bad. But anyways, you get what I was doing, okay? You got your function, derive it, find the gradient, sub y value, and so it should have been C, actually, because I just noticed something was a bit odd there. But there you go. I forgot the negative. Cool. Next one, particle. Again, kinematics is not part of the course. You can ignore this as well. Yeah, I would say ignore it. You know, don't waste time. You know, I can explain, but then I have to teach the whole thing again. Essentially, what they're trying to say is particle is at rest. At rest means when it's not moving anymore. So when you draw the graph, the only time you're at rest is if you stop. So gradient of 0, and then you continue again. So they're really just saying find when the gradient is 0. And so you're just meant to find the derivative, let it equal to 0, solve for t. Is essentially what you got to do. So you got, let's say y equals t squared minus 6t plus 5. They just want you to find the derivative, dy dt. So that's 2t minus 6. Let this equal to 0 because at rest it's a stationary point. 6 equals 2t, t equals 3. Okay, that's essentially all you have to do. But like I said, it's not on the course anymore, so don't try to understand it. Next one, absolute max, absolute minimum. Now, I did find a really cool function for you to do this. I want you to define this function. The domain is from -2 to 4, and this is my equation. So this is what I want you to do. Define f of x is equal to, now you got x multiplied to x plus 2 times x minus 3. Now I know you can sketch this. You can go to this graph here and then sketch f of x, okay? And then put in the domain to find the maximum minimum, which one is the absolute max min, yeah? But another way to do this now, okay, when you're defining, you can also give a condition, tell it the domain. So do control equals, and this is the given symbol. So given that, now what's the domain? Is from -2 to 4. That's what the domain tells me here, from -2 to 4. So I'm going to say given that it is from -2, okay, x is greater than -2, but then less than or equal to 4, okay? Press enter. So now if I sketch it, you can see, remember I can hold on to the x-axis and move it if I want. Oh, sorry, wait. If I move that, you can sort of zoom out a bit, and then you can see obviously the maximum is at the endpoint, which is up there. That's the absolute max. Absolute minimum's down here. Question is asking for absolute maximum. And that since you know it's at the endpoint, sub 4 in, because it's on the right-hand side. So you know on the right-hand side, 4 is over here. Sub 4 to find the absolute max. And you get your answer, right? So if I go back and I do f of 4, 24. So the answer is 24, right? E. But what I want to show you, a cool thing to do, is you can go to, let's go to the catalog, press F, and if you keep going down, there is a F min and F max. Okay, notice here it tells you how to do it. You write the expression and you tell the variable. Okay, so if you go to F max and you type in f of x and you type x as your variable, it tells you at x equals 4. So that's when it occurs. That's when you know f of 4 will give you 24. Okay, that's another way of doing it. Instead of looking at the graph, you can do it that way too. Okay, then we'll tell you the x coordinate, and then you do f of 4, right? Instead of using the graph. So you got f max, f min. That I've never taught. So worthwhile looking. It's in your catalog in the box. So if you go to catalog again, press the letter F and scroll down, and you'll be able to get to f max, f min. Okay, but that concludes the video for multiple choice. As you can see, the way I'm doing it, I'm really trying to use my CAS wherever I can, and the better you can picture the graphs, the better it is for you. Okay, and that's the same for 2016, 2015. Same drill. Okay, I'm going to stop the video here. I'm getting really tired, but look, I got about another hour and a half before 12, and hopefully this will prove useful for you tomorrow. Okay, here we go. Let's end the